Carbapenem resistance in VIBRIO, solving the scientific puzzle. Since the discovery of penicillin by Alexander Fleming in the late 1920s, antibiotics have revolutionized the field of medicine. They have saved millions of lives every year, alleviated pain and suffering, and have been used prophylactically for the prevention of infectious diseases. However, antibiotics have been failing to resistance for almost as long as people have begun using them. The progressive development of antimicrobial resistance is slowly jeopardizing the healthcare system. It leads to complex treatment regimes, prolonged hospitalizations, and accounts for massive social and economic burdens. This concern is real. As published in Nature a decade ago, health officials are already watching in horror as bacteria become resistant to powerful carbapenem antibiotics, which is regarded as one of the last drugs on the shelf. Carbapenems are characterized by the distinctive carbapenem structure that comprises the beta-lactam ring. This combination confers exceptional stability against most beta-lactamases, making them a broad-spectrum antibiotic. The World Health Organization has classified carbapenem-resistant pathogens based on the urgency of needing new antibiotics. Although VIBRIO species is not included in this priority list, it is indeed alarming to realize that there is an increasing trend of clinically inconsequential environmental VIBRIO isolates harboring carbapenem-resistant traits. A recent analysis reported that no single antibiotic is universally effective against all cases of VIBRIO infection due to the heterogeneous resistant patterns developed across the species, which include resistance against carbapenems. In this light, several important questions arises. It is important to understand the extensiveness of carbapenem resistance among VIBRIO isolates early and decipher the underlying mechanisms and pathway disseminating its spread. Identifying the reservoir of carbapenem resistance at an earlier phase will help to buy time to strategize appropriate measures. Therefore, we conduct a comprehensive analysis of the primary works in the literature and gather surveillance reports from various global regions to assess the prevalent susceptibility profiles of VIBRIO isolates from different settings. Our work concluded that carbapenem-resistant VIBRIO isolates have been identified in all continents except Antarctica. This suggests that carbapenem-resistant VIBRIO is a global crisis rather than an isolated phenomenon. Our findings also reported that carbapenem resistance among VIBRIO species is not limited to clinical settings, but has extended to diverse environmental niches, including aquatic ecosystems and food sources. Similarly, companion animals, anthropogenic factors, and environmental plastics are seemingly overlooked sources of contamination that aggravates carbapenem resistance. Therefore, there is a pressing need to extend the surveillance beyond these conventionally identified mediums of carbapenem transmission. Several mechanisms of resistance, which include decreased outer membrane permeability, development of efflux systems, resistant gene transfer, and enzymatic inactivations, have been elucidated. Alarmingly, carbapenemase including phenotypic and genotypic expressions have been identified in VIBRIO isolates. Deciphering the mechanisms and pathways of carbapenem-resistant dissemination helps design better prevention strategies to control its aggravation. It is our hope that this timely study will help the three protagonists to be informed scientifically the urgency of this issue and consult to take immediate action, then reflect on its effectiveness periodically so that prompt and proper control of this situation can take place. Detailed information of our findings is published in this journal, Insights into Carbapenem Resistance in Vibrio Species, Current Status and Future Perspective.